This video is brought to you by Amber. Amber keeps your EV on the road longer, offering seamless protection with no long-term contracts or upfront costs. Learn more at the link in the description and use code SPEC5 for 5% off. Howdy folks, and welcome back to another Out of Spec Renew video. Today we've got a 2017 Hyundai Ioniq here in the shop. And this car has a little bit of an interesting story. I kind of don't really know if this is going to be a simple repair or a more in-depth repair, so we'll just have to kind of go along for the ride and see where it takes us. So the story behind this car is the guy that owns this kind of bought it as a bit of a project, I guess, and he attempted to rebuild the motor in it. And I think he's actually had the motor apart at least twice, and he also put a new gearbox in it, and then apparently Hyundai actually put a new traction inverter in it, either under warranty or under recall or something like that. So it actually has a brand new traction inverter. In fact, the plastic is still on the little logo there on top. But the funny thing about this, the problem that's going on right now, is that the car is throwing alerts for stator over temperature and motor over speed as soon as you turn it on. Obviously the motor's not spinning, but the car thinks that it's spinning, at over its, rated RPM, and it thinks that the temperature of the stator is over the limits. Both the encoder wiring and the stator temperature wiring live at the same connector on the motor. So what I'm suspecting is that sometime in the multiple times that this guy has had the motor apart, either the wiring has gotten damaged, either inside of the motor or on the outside of the motor at the connector. So anyway, we're going to go ahead and investigate and see what we can find. Alright, so just to kind of show what the car does here when we start it, we'll go ahead and hit the power on. And I can hear the contactors close. They're pretty quiet. I don't know if that shows up on the mic or not. But contactors close, we get all power on. I think if I were to crank up the heat, it would probably work, because we do have high voltage power. But what we don't have is we don't have a ready indicator, and we can't put the car into drive or reverse. Can put it into neutral, but that's pretty normal. And as you can see, we do have sort of a check EV message there on the dash. So what I'm going to do is I'm going to go ahead and plug in the scan tool. We'll look at the codes and see what other information we can find as far as reported values for the stator temperature and for the motor speed. And then we'll go ahead and do a physical inspection at the actual connector. Alright, so we're connected to the car. I'm going to go ahead and hit auto scan here. And we'll just do a fault scan. Alright, so our fault scan is complete. We have a few different things. We've got some battery voltage low. I think our 12-volt battery is a little on the low side there. I should probably put some support on it. But what you can see, the main things we're concerned about is we have drive motor A, temperature circuit high, position sensor circuit low, position sensor not learned. So those are going to be our different issues that we have. So circuit low, circuit high, those are going to be, let's see, I want to go back and I want to see if we can go to enter the motor control system, and I want to see what we can see for live data. So motor temperature, well, it's actually, yeah, so motor position resolver sensor, we've got 000 on all of those. Our drive motor temperature is showing it's fluctuating between 2 and 4 degrees C. But all the other stuff, inverter temperature, drive motor, phase current, resolver offset, resolver fault counter, we have a bunch of faults. Okay. Well, so let's go ahead and see if we can unplug the connector, and we'll see what we get for values there. Alrighty, we've got the car up in the air. It's kind of amazing how much space there is in here. It's like just big empty space with a little motor in the middle. There's no cross members or anything. But anyway, the connector we're after is this one right here, which I can see it's not clipped in right there or up here. But I think everywhere else we're probably connected. And what I have here is a bit of a cheat sheet. So this is from this is all just service data that's available online. And what I have is the expected values for what we should see at the different pins at this connector. So for example, like our motor temperature between pins 4 and 8, depending on the temperature, we'll get a different resistance value. So the lower the temperature is, the higher the resistance value should be. So if, for example, there's a connection not being made here, so open circuit, it would read a super low temperature. So yeah, for example, 20 degrees C on here, which is 68 degrees Fahrenheit, would read about 12,500 ohms. It's colder than that in, the car's been sitting outside in probably, 45 degrees maybe. So I would expect to see a value probably between maybe 15 up to 20,000 ohms potentially. And then we get some values for the motor position sensor as well. So just different values in ohms, plus or minus 10%. So what I'm going to do is I'm going to set that piece of paper aside here. We're going to unplug the connector, just like so. Do I see any signs of corrosion or anything in there? I don't think so. I'm going to move my light to a place where it actually lights up the pins so I can see better. And let's see, so I'm going to start with our motor temperature, since that's an easy one to do. So that's going to be the 2 pins at the top of the connector here. I'm actually going to just hang my multimeter up here so I don't have to hold on to it. There we go. Hopefully you guys can see that. Kinda, sorta. But anyway, between pins 4 and 8, which are the 2 at the top here. Of course, I can't see anything either now. And I get open circuit. So totally open circuit there. No resistance value, which indicates something inside of here is probably not connected. We'll go ahead and check the other ones as well. So resolver pin 3 and 7, we should get approximately 76 ohms. That's the next 2 pins down. Oh, actually, I do get a value there. I get 70 ohms. Let me check back at the other one. Maybe I wasn't making a good enough connection. Oh, I do have a connection. Okay. I was awkwardly trying to hold the multimeter so I could see it before. You probably can't see the value, but I'm getting 21.9 thousand ohms, which is probably roughly in the neighborhood that we want to see. We got 70 for our position sensor, one of the position sensors. If we go to the next 2 pins, we should get 87 ohms, plus or minus 10%. And I've got 80.3, so that is within bounds. And then the next one is going to be 26.5 ohms, plus or minus 10%. I get 24.4. So we actually are all good at our connections there. So I guess the next step is probably going to be, let me see if I can just take a better look inside this connector. Yeah, no corrosion there. So I guess the next step is going to be to go up the chain. I don't think that actually doesn't quite snap into place the way that it should, but it does seem to stay on there. So I guess the next step is we're going to have to go up the chain, further up the harness, and see if maybe we have a break in the harness somewhere. Maybe the harness got pulled on and broken, or something along those lines. All right, onwards we move. Alrighty, so the other end of our resolver connections end up at the traction inverter here, which Hyundai calls the EPCU, which I guess is, I don't know, basically it's the traction inverter, and it does all the control stuff for the motor. I'm going to go ahead and disconnect our negative battery terminal here real quick, which I probably should have done before, but I don't think it was really going to hurt anything since we clearly have communication issues with that connector. But I'll disconnect that so we don't throw more faults for this thing. And then what I have here is I've printed out a wiring diagram that shows all of those same pins that we connected and what pins they're at this connector on the EPCU. I keep wanting to say ECPU. So that's just a little rotate and unlock on that connector. And the light that I have on here is not super bright, so let's get something a little brighter, a little more direct. Oh, that's not magnetic. There we go. So, can I see pin numbering here? So I'm back with our harness guide that shows our pin out here. I'm going to need a couple of teeny tiny little pins in this out, which I thought I had here. Oh, here we go. I really need to get some better little probes. Anyway, I'm going to set this up right here. And what I should be able to measure is that this connector should be able to measure between 1 and 2 are resolver plus and minus, which based on our other cheat sheet, resolver plus and minus are pins also 1 and 2 on our connector at the motor. So I should be able to put these in. Oh, wait a minute. Actually, we want to go. Oh, right. Yeah. Resolver plus. So this is actually pins 1 and 5 on the motor. Pins 1 and 2 right here. And we should get our whatever 20. I think we measured 22 point something on the motor. 24.9. Okay. 25. So that's about right where we need to be. So our temperature, we want pins 34 and 50, which are also on top of each other, but at the bottom of the connector here. And based on our measurement before, I think we had measured about 21,000 ohms. 19,000. Seems pretty close there. So it seems like all of our connections are indeed correct. Our resistance values are correct. So maybe we're dealing with a ground issue here. Perhaps the motor is missing its ground. Let me go ahead and bring the car back up in the air. We'll go ahead and check for grounds, because all this stuff seems okay. So maybe our sensor ground issue, yeah, maybe we just have a sensor ground problem where that's interfering with our ability to make proper measurements. All right, so I've got the car back up here in the air, and I did take a quick peek before I turned on the camera, and I did spot something that does look slightly suspicious. But before I point it out, I want to see if my idea is confirmed. Maybe not, because I'm getting a good connection here. Let me try something else here real quick. Alright, so this is just another one of those issues where it's kind of a head scratcher harness issue. So right now, I have multimeter pinned out between the two pins here that would be sensors, what is it, 2 and 4, I think? Yeah, 2 and 4 for the resolver. And you can see we have no resistance. We should have somewhere in the neighborhood of about 70 ohms. If I reach down here and I grab the harness and move it just a little bit, you can see we get our reading that we should have. I'm not 100% sure at this point if it's a break in the harness or a problem in the connector itself. So I'm going to pull the harness back up here. So this is the connector that plugs into the motor resolver down there. So what I'm going to do now is I've got just another little lead here that I can attach. And so pin 19 goes to 2, sensor 2. Sensor 2 is pin 4. No, pin 3. Oh. Reattach that. We want to go to pin 3, which is, let's see if this were facing that way. It's going to be this one. So there you can see we have good continuity. What happens if I flex this around? Okay, our continuity seems to be unchanged. So let's swap to the other one. Okay. Yeah, see, this is just a real puzzler because I don't know what is causing our loss of connection here. And it doesn't seem like it's right here at the pin. I was thinking it was somewhere down here because it feels like there's some splices or something in there. That all seems fine. Well, maybe it's a problem with the pins themselves. I mean, they look fine. Yeah, I mean, the pins don't appear to be damaged. I run this in here. I mean, it doesn't feel like any of the pins are spread out. Maybe it is a problem with the resolver connector down there, but it just seems a little weird. I did notice that the resolver connector, the bolt that actually holds the connector onto the motor, is stripped out. So the bolt is basically just sitting in there not doing anything. Maybe that's got something to do with what we're seeing here. I might have to pull the cover off of the resolver, whatever casing on the end of the motor. And yeah, I mean, that might be what we have to do. This isn't making sense what I'm getting here, because I was getting variable results down below when this was plugged in. I moved it around, but now everything seems hunky-dory. Maybe I'll try and put the multimeter on the actual connectors on the motor and see if we get any results if I kind of jiggle that connector around a little bit. Alright, so we're back on this one. It's actually the next day. I kind of had to take a little bit of a break from this and try and think about what was really going on, because it seemed like I could get a connection when I toned out all the wiring and stuff. But if I left this plugged in and measured everything up at the top, sometimes I could get good readings and sometimes I couldn't. So that made me think of actually the Fiat that we repaired not that long ago, where we had a broken wire. However, there's no broken wires here, but what I did discover is that apparently this has been plugged in and unplugged so many times that the pins, the actual inside of the pin, where it makes contact, so this is a female pin, the male pins are on the motor side here, and the female pin, there's sort of like a little spring, for lack of a better term, you could call it like a spring-loaded contact. It's basically just a little bent-up tab inside of the pin that puts pressure on the male pin when it's inserted. However, if I take one of these pins and put it where it's supposed to go, it's super loose. I mean, it probably won't really show up on camera, but there's zero resistance to this thing when I try and push it on and off. It's basically just sitting on there, and I can wiggle it around back and forth. So while I was making enough of a connection to be able to measure the resistance values that we needed to from this connector, I think that the connection was just so poor that, especially for the power side on the encoder itself probably is not getting the actual power that it needs to be able to run everything here. I did try to see if I could bend the tabs on these pins out, but there's not really any way to get access. Sometimes pins have a little hole on the bottom where you can shove a little pick through it and bend that tab back up, but these ones don't really have anything like that. There is a little bit of access on the back side here where I can try to maybe push the tab up, but I don't think it really works that well on these. Yeah, like right there I tried. It made it a little bit better, but definitely not good enough. Well, I mean, it does have some resistance if I push it on there. I might try and depin these and try and bend the tab up and see if I can get a better connection on them. The two that I really care about are the power wires for the encoder, because I think those are the ones that are going to matter the most. But mainly I want to see if I can get this to work again just by doing that. And that'll certainly give us our best clue that we're on the right track. I think ultimately what this probably needs is going to be new pins to be crimped on here, or a whole pigtail with wires already attached. This connector is made by a KET, K-E-T, which is a Korean company. Of course, Hyundai being a Korean car, it would make sense they use Korean connectors. They don't have this connector from any of the normal like online distributors for electronic stuff like DigiKey or Mouser or anything like that. But there are some automotive connector part sites that do have it as a pigtail for really expensive. There's also another website that I can try and order one of these as well, where it's just the bare connector with the pins, not with any pigtail crimped onto it, which I think is what I would prefer to do here. Basically just cut these off as close as I can. I mean, there's quite a bit of slack in this harness. But anyway, yeah, I'll see what I can do as far as that goes. But first, I want to try and bend all the tabs out on these pins and see if we can get a better connection. I might even try and just depin all of these and just put the pins on the connector. Well, yeah, I'll just try and bend all these tabs out, put it back together, and see where we get. Alright, so I've bent back all the pins as much as I could. I'm going to go ahead and reconnect that, which it doesn't, the snap on it's busted. That's another reason why this should probably be replaced, is the actual snap doesn't hold the connector on there. We'll go ahead and turn the light off here, bring the car back down, reconnect the 12-volt battery, and see if we get any signs of life. Alright, car's back down, 12-volt battery's reconnected. Let's see if we get anything new this time. Okay, I do still have alerts present. But maybe those will clear. Try and reconnect. We're connected. Okay, let's try and erase. Read. Nope, no change. We still have our circuit low. Position not learned. Same old stuff as before. Well, I thought maybe that was the problem because those pins were pretty loose. I mean, they're still not perfect, so it's possible that we could still be having an issue there. But well, back to the drawing board, I guess. Alrighty, so things have escalated since the last clip I filmed. Honestly, I was getting a little bit frustrated with this car, trying to figure out what exactly was wrong with it. I toned out all the wiring. Everything seemed to make sense, and I just could not figure out what the issue possibly was. And part of that is a little bit because Hyundai's testing methodology for the alerts on this were a little bit misleading as far as this particular issue goes. What I should have done, and I kind of did take this into account, but I know that this motor has been apart multiple times from the owner that has rebuilt it. And I did think about, potentially the connector or the wiring got damaged when he had it apart multiple times. But what I didn't think about was the potential that something else could have been misplaced or not assembled correctly to cause this problem. And so what I ended up doing is I took the resolver cover off here, which is quite a bit of stuff. I have to unplug the three-phase connector from the traction inverter. There's a plate up on top where you get access to the 3 bolts that hold the connector on. So they all go into the top side there. And then I was able to pull the actual cover off, which looks something like this. So that's the cover that lives on there. Actually, it goes just like so. But what I discovered was that there is indeed a problem with not necessarily the resolver itself, and definitely not with the wiring, but rather the placement of the encoder ring. So I'll bring you guys up close and show you what I'm talking about. So here we are up close looking at the resolver. And basically the way that this works is the resolver sensor here has 2 sets of sensors in it, and then it has a power supply. So you can see our wiring here. I'm assuming the red and black is the power supply, and then all our other ones are the actual sensor outputs. But basically, this is kind of like a Hall effect system. So all these little metallic bits that you can see around the periphery here, these are all kind of like a magnetic sensor. And what they do is they detect the lobes of this ring. So we would call this like the encoder ring, or I guess a resolver ring. I'm not totally 100% certain what the correct term for it would be, but basically those are picking up the Hall effect sensors in there are picking up the lobes of that as this spins around in the motor, and it tells the inverter how fast the motor is spinning, so that it knows what's going on. But the problem that we have here is that it doesn't line up. So the edges here, I don't know how well it shows up on camera in terms of perspective. That kind of shows it pretty well. But the edges should line up here. But instead, our encoder ring, so the part with all the lobes here, is sitting too far out in relation to the actual resolver sensors. So I think that the problem is that the resolver isn't actually picking those up, so it has no idea what position or speed the motor is in. What I suspect happened here is that in the multiple times this motor has been apart, the last time it got put together, it probably was assembled incorrectly with either spacers on the wrong side of bearings or something along those lines, and the whole rotor in the motor, so the rotor is the part that spins, I think that the whole rotor is shifted out this way too far. Probably, I haven't taken an exact measurement, but it looks like maybe somewhere between 1/8 and 1/4 of an inch, which is enough to make that not line up. So without, I have a theory for a plan to test this theory without pulling the whole motor out. In my opinion, the whole motor should probably be pulled and gone through, just because not only is that an issue that I've seen, but I've seen a few other problems like, a stripped out bolt here, there was a stripped out bolt on top, some other fasteners that are totally loose, like that one right there, and there could be some other stuff that I'm not seeing here either. So I think it's probably best that this comes apart, to rectify the rotor positioning issue, but also to make sure that there's no other problems going on in here. Because yeah, like I said, this guy has had this motor apart multiple times because he's had issues the first time that this was put together. I think it's been apart twice, but maybe 3 times? Not 100% certain, but basically it's been apart multiple times, and there's been some mistakes along the way. So that's why he brought it here, was to have me take a look at it and hopefully make everything right. But as far as my plan to test my theory as with that being displaced, short of pulling the motor apart and rebuilding it, what I'm going to do is I'm going to unbolt the resolver here, and I'm just going to put washers behind it to space it out so that it lines up with the encoder ring, and I'll just put the cover back on, reconnect the motor, and we'll see if we can start the car up and see if it actually works. I think that's going to be step 1 here, and we'll see where we get from there. Alright, I've got everything loosely put back together here. I'm going to go ahead and power the car back up. So our high voltage disconnect lives in the trunk here. I'll just get that in, snapped into place. Get our 12-volt battery reconnected, and let's see what happens. Okay, I do have alerts present, but we might be able to clear that with the diagnostic tool. I'm not so sure that that's a code that'll self-clear. So let me grab the diagnostic tablet and we'll see if we can clear that out. Alright, so we're connected with the scan tool. I'm going to go ahead and try to hit erase here. Yeah, I do still have the same code. Well, maybe that wasn't our problem. Yeah, this is a frustrating one. Really not sure what's left to try here. Alright, honestly I'm not totally 100% sure what I did here, but I managed to get the car to turn on. I did unplug the EPCU to check the resistance values and stuff on it, make sure everything had a good connection, which it did. And then I plugged it back in and I made sure to kind of give it an extra push. And then I tried to power on the car and it went into ready. So, I mean, right now it'll go into drive. And it started spinning there when I let my foot off the brake, as you probably heard. In fact, it started going really fast. I do have a power limited though, and an EV, check EV message, so let's try and erase codes here. I want to go just key on. I don't want to have the car in ready. There we go. Yes. Okay, and now I will power on. Read codes. Okay, so now the only code that we have is the position sensor not learned, which I kind of anticipated. If I go back and I go to special function, we have a calibration procedure. So I'll hit OK, ignition off, and turn ignition on. Press OK. Okay, the function has been initialized. When the vehicle is driven at a speed of 20 to 50 kilometers per hour, the resolver is in learning mode. It operates in coasting operation for status of 2 seconds regardless of APS. Okay, so I think all that I need to do is basically drive the car at over, between 20 and 50 kilometers per hour. So I'm just going to do it right here on the lift. We'll put it in drive. Okay, I think it's unhappy because we're off the ground and the ABS is kind of kicking in. I might have to put the wheel and stuff back on and get everything put together a bit more to actually do this properly, but anyway, yeah, we'll try and see if we can make that work. All right, we're getting ready to head out here on the street. We'll go ahead and initiate our thing. All right, we have to go ignition off, ignition on, press OK. Okay, it's been initialized. We should be able to drive. And then the code should clear automatically if our process here works. So let's go and drive. Motor bearings do not sound particularly happy. Definitely pretty loud. So far, doesn't seem to be automatically clearing that resolver offset. Alrighty, so I got the car back to the shop. I did drive it around on a little bit higher speed roads, and the check EV and power limited didn't go away, but I discovered that it did actually complete the resolver learning process, but it now has the code for the motor temperature circuit high once again, and you can see we're reading 214 degrees C on the motor, which is clearly not right, which makes me think that maybe we have a connection problem again. Although I'm not seeing any values change there. Interesting. That's interesting. So when I wiggled that connector, I heard the motor move, which makes sense considering what happened before, because I was able to get this working by pushing that connector in, so there must be some loose pins here too. Alright, it sounds like we just have a bunch of different things going on here all at once, so let me see what else I can figure out here, and we'll go from there. Alright, so I got in touch with the customer, and he does indeed want me to go ahead and pull the motor out of this and go through it, which was kind of his original plan in the first place, bringing it to me. I think after his multiple attempts at trying to rebuild this thing, he decided to have a professional take a look at it. So that's what we're going to do. I'm going to go ahead and get started pulling the wheels and stuff off. And the motor on this should be pretty simple to pull out of the car. There's a lot of access and space in there. And unlike some of the other Kia Hyundai models where the inverter and stuff are attached on top of the motor, in this case it just has that cable assembly that plugs in. So there's not going to be a ton of stuff to disassemble to actually get it out of the car. So yeah, it should be pretty simple to at least get it out. And then we'll try and see if we can set it up on a stand, and we'll take the thing apart and see what we find. Alright, so motor's out of the car. At first glance, couple things that I'm noticing here. It looks like, I didn't really notice this before, but there's a little bit more of a gap between this end plate and the motor housing than I think should be there. And then this seal on the end, they removed it and then they tried to reinstall it. And you can see it's pretty beat up. And actually, I think it's installed backwards. I'm 99% sure that that seal is supposed to be on there the other way. So that's that. And I think that's pretty much all I see here. I definitely know that there's going to be a few fasteners that we're going to have to helicoil. I know the one for the connector here. I swapped out this fastener for one that was just a little bit longer, but it's in there, maybe like 2 or 3 threads holding that in. So I'm going to have to helicoil that. I think one or two of these ones up here at the top were stripped out. Looks like there's a little piece of the casting there that got busted off at some point. And I think that one of these might have been stripped. Either that or it just wasn't fully tightened down, because I know one of those was pretty loose. Obviously, I don't have all the fasteners in here. They're supposed to be there since I did a brief test with this thing to make sure everything worked. But let me see if I can figure out a way to rig this up on one of my motor stands. It looks like there's not going to be an easy way to mount it. So I might have to rebuild this on the bench rather than on the stand, but I'll see what I can figure out. So unfortunately, this motor doesn't have any convenient places to mount it to a motor stand, so I'm going to have to kind of rebuild this the old-fashioned way on the bench here. Luckily, it's not too heavy of a motor, so it's relatively easy to manhandle. In fact, I'm actually just going to pick it up by hand and set it up here on the table. I'd say it weighs, I don't know, maybe 100 pounds or so. I mean, it's heavy, but it's not that heavy. So, I've just got a piece of cardboard here so that we can kind of protect it from the table surface. And the rotor in this is actually it's a permanent magnet motor, so the rotor's magnetic. I don't want to be setting it directly on the steel surface and getting a bunch of contaminants and stuff on it. But yeah, let's go ahead and start tearing this thing apart. All right, so first thing, I'm going to go ahead and pull off all the stuff that we had removed before. This side of the motor shouldn't really be very removable because the phase wires have to go through here. I mean, it might be if we were to bend the phase wires out of the way, but it's not really a great plan. All right, so I've got the motor repositioned here a little bit so that our end plate is kind of hanging over the edge of the table, and I've actually got the motor strapped down so that it's not going to move around on us. These the rotors on these permanent magnet motors can be a little bit tough to pull out, so it's going to make it a lot easier that we have this out. I'm noticing here the splines have a little bit of wear, but not too terrible, so at least it does that. That's interesting. Is there a water jacket in those holes? That's very unexpected right there. Try and grab a catch container here so we don't make too big of a mess on the floor. Let me see if I can get this end plate separated off the motor. Alright, first I'll try and get it tapped loose just with a soft blow mallet here. Yeah, I did not expect that was going to be water jacketed where those bolts were. Almost makes me wonder if there's something else here weird going on, or if this is just slightly different design for the motor than I was expecting. There we go. It's starting to move for us now. Yeah. So I should be able to pull on it now, I think. Let me lock the wheels on the table so it doesn't move. Ooh, yeah. Smells like this thing got hot. It definitely smells a little burnt. And it appears, looking at this, yeah, that's interesting. That cooling jacket is kind of weird. So it's actually the cooling channels that go around the outside of the motor here. So you can actually, now that I'm looking at it, I can visualize that each of these is a cooling channel. And they're kind of looping there at the end of the end cover on the motor. That's interesting. It does not appear that any coolant has gotten into the motor itself, which is good. But it's kind of an odd design that they would have done it that way. I'm going to leave that gasket in place. It looks like it's in good condition. I would say that that's reusable. I mean, it's highly doubt. There's no way that I'd be able to buy this gasket. So if I did do anything about this, I'd have to put some silicone sealant in there. I'll have to think about whether I want to do that or not. I definitely want to clean out the particulate in here. The guy said that he had some bearings in here. I think they were some ceramic bearings, but maybe they didn't have any lubrication in them or something. But he said they basically, quote-unquote, exploded. And maybe that's the particulate that I'm seeing in here. I mean, it's all over the windings and stuff. That doesn't seem great, but I think it's okay. I mean, there's no isolation faults or faults, you know, for the stator here shorting out. Definitely don't like seeing all that particulate stuff in there, though. Anyway, back to the rotor. Let me move you guys over there. So on the rotor side of things, this bearing feels okay. I don't feel any like divots or anything when I try to spin this bearing. But the one on the other end, I can feel definitely has like some imperfections. That could have been from beating the bearing on there. That can damage the races. Or in the case of, you know, just regular steel bearings, it can damage the balls too. But usually it damages the races and basically causes divots in them. And you can feel that when you rotate this around. And looking in this gap here, I'm pretty sure these are 6007 bearings. That one doesn't actually say, but if they are 6007s, they're 1 millimeter narrower than the factory bearing on these, which is a freakish, like, oddball size that you can't buy anywhere. It's like a proprietary size that Hyundai and Kia used for these motors. But the typical solution is to use the same size bearing that you'd find in a Tesla large drive unit on the rotor, which is a 6007. The only difference in sizing for that bearing is that it's 1 millimeter narrower this way. So you have to take up that extra space with basically just a spacer, a shim. And what I'm guessing here, based on what I'm seeing, is that they didn't have any shims in here, which might be why this didn't line up. At least that's going to be my best guess here as of right now. Actually, looking at this, it looks like there's a gap on this end. How would that even be possible, though? Well, let me see about getting our this end cap off. There's a bearing retainer behind here with 3 bolts. I'm sure you can see that one there, and then there's 2 others. We'll get that bearing retainer off. We'll get the plate off of here, and then we should be able to take a closer look at the bearing on the other end here and see if we can figure out any other clues here as to what's going on. There we go. So that is off. Oh yeah, that's super crunchy. That's definitely our problem there. Yeah, it's hard to even spin that by hand. So this bearing is definitely pretty screwed up for sure. Yeah, and there's definitely no spacers in here. And this bearing is not fully seated. So yeah, that kind of confirms my suspicion that that it was a spacing issue on that, because the bearing is not fully seated on here, which means that this was pushed out further than it was supposed to be. So, suspicion confirmed on that one. Now I've just got to go ahead and get these bearings off, and we'll install some new hybrid ceramic bearings, the same ones that I would use on a large drive unit, with the correct spacer rings to go in here. And that should be good to go. Let me grab my puller and stuff, and we can get started on that. Alright, we're going to go ahead and pull our bearing off here. So I've got it got the puller on here. I should be able to just crank it down. Alrighty, that is off of there. Yeah, you can see just how hot that shaft got. It's pretty blued, and it looks like maybe it's a little bit galled up. I might even try and hit that with just a little bit of sandpaper or something. Try and clean it up a little bit. I believe, actually, now that I think about it, I think there's supposed to be a snap ring that goes here, which I think I remember from the last time I pulled apart a Nero motor, which might also explain why the rotor got displaced like it did. It may have actually slid out of position without that snap ring. I might have to see if I can source a snap ring in the right size. And then the other thing that I'm going to have to source that I don't have in stock is the seal that goes in the end of the rotor that or the end of the end cap for the motor that we talked about. But anyway, there's that bearing. It's pretty crunchy. I'll put it up by the mic. Don't know if that picks up on camera or not, but it's definitely a pretty crusty bearing. Timken. I wonder if this is a steel bearing or a ceramic bearing. Anyways, yeah, that one's junk. Might pull the seal off of it and look inside just to see what it looks like, but definitely needs to be replaced. And the one on the other side, we'll go ahead and pull that one off real quick too. Alright, so to pull the bearing off of this end, I'm going to have to put something in here to center our puller. It's actually just an extension. It works just about perfect though. And what I'm going to do is I'm going to actually pull off this encoder ring, because that'll have to come off first before the bearing. So we'll get our puller cranked down. I might have to switch to a 2-jaw puller since this has 4 lobes on it, but I might be able to get it with the 3-jaw. I just don't want to damage it. I think we'll be okay there as long as I crank this down enough. I'll just go slow and careful. Oh yeah, that's pulling off easy. Okay. Okay, so that's our encoder wheel and the little press-on sleeve that holds it into place. Now we can go ahead and get the bearing off. Oh. Alrighty, we'll set that bearing aside. Well, actually, they did have a spacer on that side, but technically that would be the wrong way around, wouldn't it? I think so. Can't tell if that's factory or not. I might have to look into that a little bit closer because I'm not sure if this actually belongs in here or not. So I think I realized what this spacer is from. The way that this guy assembled this motor is the opposite way of what I would normally, what's generally considered to be the accepted method for rebuilding these with the slightly narrower bearing, and he used a spacer on the inside rather than on the outside. Normally the spacer would be, well, I can grab one and show you real quick. Let me get it. So the typical expected method for using spacers on these would be to use a larger spacer that's the same OD as the bearing. But instead this guy used one that's the same ID as the bearing, which I suppose functionally might kind of do the same thing, but there's some problems here that I can see that it caused. And actually, this is actually one of those spacers, and it's like physically welded on to the end of the rotor here. Hopefully that doesn't cause too much of a problem to get it off. In fact, let me see if I can grab it with the puller here and get it off of there. If not, might need to get a punch, like a chisel, and try and break it loose. Because yeah, I think that's part of our problem here, is that that is kind of welded itself into place. And I can see that it's kind of deformed around the edges, which definitely seems to be causing a problem. Yeah, this thing is pretty messed up. I actually get this spacer off of here. Just have to make sure to remember to put this on before the bearing goes into place. Alrighty, I got a little bit sidetracked there with a phone call and some customer walk-ins and stuff, but we were working on trying to get this off. So it is pretty well stuck on here, but with just a little bit of persuasion, I think I can get it separated here. Part of the problem is that the magnetism wants to help keep it stuck on here. There we go, finally. That thing is pretty mangled, for sure. I mean, it was basically kind of welded on here. I'm going to have to see if I can clean up this shaft, probably with a little bit of sandpaper or emery cloth or something. And, yeah, that's pretty galled up. That's probably why they couldn't get the bearing on here all the way. Is just because that shaft was so galled up. So they probably didn't get it fully installed. I think that might have been a big part of the problem here. So I'm going to try and clean that up a bit, and then we can go ahead and get started installing the new bearings. Alrighty folks, we're back on the Ioniq motor here. It's taken a little bit longer than I had originally hoped to get the parts. Part of the problem is, one, the broken connector on the motor was a bit tough to get. Had to order that from overseas. But I did get a new one, so we have a new connector housing for that doesn't have a broken snap, so that issue is addressed. And then, of course, our seal in the end cap of the motor here was destroyed, so I had to source a new seal. This is like the most freakish size, non-standard seal, so it was a little bit hard to find. Technically, this seal is a little bit off in size from the original, but it was the closest thing that I could possibly find, and it should do okay. Really, the purpose of this seal is just to keep dust and contaminants out of the end cap of the housing here. And that's the replacement seal. So the original one was a 27.5 millimeter ID. This is a slightly looser fit, but it does still seal on the shaft there. So I think we'll be okay there. It's at least way better than what was on there before. The actual seal size that is supposed to have the 27.5 millimeter ID is just unobtainium. It's impossible to find. It's going to be some proprietary seal that Hyundai spec'd for this, just like the bearing sizes, which are also a non-standard size that's impossible to get. So these were the bearings that the previous guy did put on that were the available size that's slightly narrower than the originals. What I am going to do differently than what he did last time he attempted to rebuild this, he put his shims on the inside race of the bearing. It's actually going to be better to go with some shims on the outside races. So that's what I've got here. And I think we're pretty much ready to go ahead and start putting this thing back together. The other thing that I did off camera, you'll notice that the rotor is all taped up here. I actually ended up bringing it into a machine shop to have them clean up this bearing surface, just because it was so galled up. It had a bunch of high spots, and it was just a little bit too oversized on the diameter for a bearing to be able to fit properly on it. So I brought it into the machine shop to have them clean it up a bit. It's not 100% perfect, but it's a heck of a lot better than it was before. And the bearing should be able to fit on there, hopefully without too much of a problem. So anyway, now we're pretty much ready to start putting this back together. The other thing that I'm going to do here is this gasket is another one of those parts that is just not obtainable. You cannot purchase this gasket. And there's a few issues on the sealing surface of the actual end cap on the motor here, probably just from it being taken on and off multiple times. You can see there's a little bit of some chowdered up stuff going on there, a little bit around the holes, just a few other rough spots. I'm probably going to hit some of this with a file a little bit just to try and clean up any high spots. And then I'm actually going to take this gasket off, and I'm just going to give it a real thin skim coat of just RTV gasket maker on both sides, just so that we can ensure that we have the best possible seal here. Because if this were not sealed, it could potentially leak coolant into the actual stator housing. I am seriously considering pulling off The other side here, I know that I mentioned before that I didn't want to have to bend the phase wires off of there to get this off. But after seeing the condition of that side, I'm a little bit concerned that we could end up with a similar situation on this side as well. And I just want to make sure that it's properly sealed. We don't want to put this back together and have it, have an internal leak just due to sealing problems. So I think I am probably going to pull this side off, which is going to mean that we're probably going to have to bend these at least a little bit. I hate bending phase wires, especially in this case where we know it's been apart multiple times. Copper work hardens every time that you bend it, and you run the risk of, with too much work hardening, you could end up actually breaking some of the copper wires in there. So I wanted to try and avoid taking that apart. If this were a fresh motor, I would leave this together because it really shouldn't need to come apart, but I'm pretty sure, you can tell just the witness marks on the bolts that this has been apart before. So I think I want to take it apart one last time just to make sure everything's sealed up there as well. And as you can see, we're going to have to clean up all of our sealing surfaces from the gasket maker that was on here, probably from the first time this was rebuilt, maybe. I know that when I took this apart the second time, the pieces that went on here were not adhered, and you can see actually there wasn't any gasket maker applied to it, at least in this section the second time. So yeah, we're going to get all that gasket material off and reseal it properly for this thing to go back together. Alrighty, so we'll go ahead and loosen our phases off here. Alright, those actually bend a little bit easier than I thought they would. Set these fasteners off to the side here on my tray. And on this actual block, it appears that we can just leave that in place. Then we'll zip out all our larger fasteners here. There we go. Now we can take this gasket off. Again, there are a couple spots where this is a little bit bent, and we do have sort of some little surface level gouges and stuff in here. So I am glad that I took this off. We'll be able to clean all this up, and again we'll apply just a real thin skim coat of silicone on both of the gaskets before we bolt all this together. Alrighty, so we've got our gasket out here on the table, and I am going to go ahead and just apply basically just a real light skim coating of silicone gasket maker on it, just so that we can ensure that we have the best possible seal. This process can be a little messy. I'm not going crazy here, I'm just applying enough to get a real light coating just to fill in any little imperfections or anything like that that we might have in our sealing surface, or any defects in the gasket here since it's been apart so many times. We want to avoid those types of issues. Alright, so both sides of our gasket have got a nice thin skim coat of gasket material. We'll just get that fit on into position here. Actually, I'm going to just tip this up on its end because it's going to make it way easier to install everything. Okay. And then our bottom side here is mostly clean. I'm going to hit it just real quick with some acetone, and then we'll go ahead and slap it on there. And then I think the temperature thing I can get set up when this is already mounted on here. Alright, looks like we're pretty much on there. Might just need a couple of light taps with this. Alright, so we've got our stator temperature wiring right here. This little grommet just squeezes up into that little round part at the top of the opening. And then our connectors just snap together like so. I'm actually going to pull this connector out because we need to helicoil this bolt hole. And then, like I said, we have a couple on the end of the thing here that also need to be helicoiled. And I think everything else here is okay. It's just those three, at least on this part. Alright, so I actually swapped out the original bolt that holds this in with this one, which is a little bit longer than the original, but it's only holding it in by maybe like, I don't know, 2 threads or something. I mean, yeah, so right there it's just slipping out. So there's barely anything holding it in there. Go ahead and pull this out. Dang, well, maybe rather than trying to pull that out, I'll just twist it off to the side here, where it's out of our way. And I'll show you what's actually up with this hole. Focus. There we go. So you can see the threads are stripped out of it except for at the very bottom. So what we're going to do is we're going to go ahead and repair the threads on this with something called a helicoil. Or at least that's like a brand name. This one is not actually a helicoil. This one's a fix-a-thread. Same, only different. But basically the way that these work is they're a threaded insert that's sort of threaded on the inside and the outside. If I can get the camera to focus on it. Come on, focus. There we go. And you can see it's basically just the threads themselves. And it's just an insert. And it has a little tang on the end here. That helps for the installation portion. But basically what we're going to do is we're going to drill this hole out slightly bigger to accommodate for our insert there, and then we're going to tap the hole with a tap that's the same thread pitch as the original M6 bolt, but just slightly larger diameter. And then there's just a little installation tool to install that, the threaded insert. And this is just a 1/4-inch drill, so it's slightly bigger than the original hole size. Alright, so I've got my tap handle here, and we're just going to thread this hole. The important part is making sure that we're straight and lined up, and that we're not crooked, because that can definitely cause some problems. Then I'm just going to go until we bottom out there. We'll back our tap out of the hole. Let me just blow the chips out of that real quick. Sweet. And now we can install the insert. Oh, I almost spilled all my inserts there. That wouldn't have been any good. So our installation tool is just this thing right here. You can see it just has a little tang in the center of it. And that tang just lines up with that, that little bit right there. So now what we'll do is we'll just get that lined up here. And we'll just thread that guy in. And I don't want to thread it in super far. I just want to thread it in enough that our threads are fully inserted. Yep, so there we go, just perfect. And then the last step is that little tang in there. We want to break that off. So you can do it with a little drift punch or a screwdriver. I don't know if I have a drift punch that's small enough to fit in there, so I'm just going to do it with a little screwdriver here. This screwdriver's not even small enough. Well, I can do it with this. So I'm just going to stick that in there, give it a little tap with the hammer, and it breaks that little tang right off. And then I just have to grab it out of there, which I think I can do with, where's my really narrow pliers? Oh, yep, there we go. I dropped it on the floor somewhere, but I did get the little tang out. So now I can rotate this back to its position, and now I can put in the correct bolt that's supposed to go in there. And now it threads right in, perfectly fine. And there we go, now we're good. And then I can just plug our connector back into the back side there. And then we're all good on this side. I just have a couple of other helicoils to do over there. And then we can start putting the rest of the motor back together. Alrighty, so I'm about ready to start installing our bearings here. I'm going to go ahead and actually peel off my protective layer here. I just did this so that any like metal particulate or anything didn't get stuck to the rotor when it went to the machine shop or when I was handling it around here and stuff. Just want to try and make sure it stays clean since it is magnetic. Don't want a bunch of stuff sticking to it, because everything does indeed want to stick. I think we're pretty much good there. So I'm just going to set that down, and now we can install our bearings. So like I said, I did bring this into the machine shop, had them clean that up a little bit. Definitely improved it big time. And I'm just using my hybrid ceramic bearings here. These are the same size bearings that I would normally put in a Tesla large drive unit. The only difference is that for this installation, because the bearings are slightly too narrow, I have to install a 1mm shim. The original bearings in this are a 15mm wide bearing, which is impossible to find. It's like a proprietary size that Kia and Hyundai must have spec'd for these, and it's not something that you can just buy on the open market. Whereas this is just a standard 6007 size bearing, so exact same specs, just, you know, slightly narrower. So we'll be fine to install that with our shims, and that's seems to be generally accepted repair method for these in the repair community. I haven't seen a ton of people do them on the original Ioniq like this, but it's a very similar motor to the Kia Niro and the Hyundai Ioniq, or Kia Niro and the Hyundai Kona. Basically, you know, sister cars to each other. We're going to go ahead and get this thing in here. So go ahead and get our bearing started. Then I've got my sleeve here. We're almost there. All right. That is fully installed on there. So we're good to go on that side. And now I will simply flip this around the other way. And then we're going to do the exact same on this side. Alrighty, so I actually made a slight mistake when I first installed the bearings on the rotor here, and that was that I forgot to put our retainer ring on. But I've got that in place now. Now we can go ahead and install our end cap. So I do have the shim in it. Very important. Don't want to forget that. And then I'm actually going to pull this out slightly. And then I'm just going to go ahead and get this lined up on here. And then I can go ahead and get the bolts started, which is easier said than done since the rotor is pulling on them constantly and wanting to suck them back out on me. Alrighty, those are all nice and tightened up. And now we just got to install our seal over here on the end. Alrighty, I've got our seal right here. Probably would have been smart of me actually to install this before putting this on the rotor, but that's fine. It's just a little bit more tricky this way. I did put a nice healthy coating of grease on the lips of the seal. If I would have done this before putting the rotor in, I could have just used a regular round seal driver, but I kind of painted myself in a corner here, so I'm just going to gently work the seal in bit by bit around the edges, just with a block of wood. I don't want something hard that's going to damage or potentially bend the metal casing of the seal. We just want to drive this thing home. It's not a super tight fit either in the bore, so. Okay, I think we're flush all the way around, so that should be good to go. Alrighty, now comes the fun part, and that's putting the rotor in. I've got my gasket here, which I've coated on both sides with just a real thin skim of gasket maker, just like I did on the other one. So we get that into place. Let me just kind of wipe my hands off here a little bit. So now I can go ahead and take our rotor, and it's going to want to kind of stick to the sides. Let me make sure I get the orientation correct here. Is that right? Well, guess I don't have to be too spot on for now, because I can always rotate it a little bit once I get down here a little bit. Okay, so I'm going to go and look on the car and double check my positioning. It can only really go one of two ways because we have some indexing things. So it either goes that way. Actually, it might be identical in either direction. Bolt pattern could be offset too. Oh, yeah, the dowels are both on the same side, so you really can only get it on one way. Okay, so I'm just going to push. And right there, we're pretty close. It might be sucking the rotor to one side or the other. So what I'm going to do now is I'm basically going to get all of our bolts started. And then might need to tip the motor on its side and give it just a little bit of persuasion. Yeah, and I can only get these in about one thread. So I probably don't want to try and tighten them. Let's see, I might try and just give them a little snug just by hand. Oh yeah. I can feel it slipping into place. Yeah, because now it's going pretty easy. There we go. Alrighty, so I've got the motor back up here on the bench. As you can see, if we take a peek in here, focus, our resolver now lines up perfectly with the encoder ring, which is what we want to see. That's great. The problem before, why the car wouldn't run, of course, was that encoder ring and the resolver were out of plane with each other. They didn't line up. And of course I made it run by putting some washers behind the encoder ring, but now, I put some washers behind the resolver. And of course now the resolver is bolted in the way it's supposed to without any spacers or anything, and now everything lines up the way that it's supposed to. So now our next step is we're going to go ahead and get our end plate back on here, and then we can reinstall the electrical connector and then the little top block-off plate. And then this thing should pretty much be ready to go back in the car after that. Motor's all back together. I got the connector back on and the top plate. All that is pretty much just the same process as everything else here. And yeah, so now this thing's all assembled and we're pretty much ready to put it back into the car. The only thing left that we need to address is the electrical connector that actually plugs in for the encoder sensor there. So that just snaps on here like so. Oh, there we go. Yeah. So snaps on there like so. The original one on the car, the actual snap on it's broken, so it doesn't want to stay plugged in necessarily. I was able to drive it around like that before, but I would be very worried about it not wanting to stay together. So all we have to do is just de-pin the original connector on the car and then insert the pins back into this connector, and it should be good to go. Alrighty, so our harness is all reattached to the new connector there. So now I just have to rewrap this in electrical tape, just like it was before. I'm all out of fabric tape, so I'm going to use some vinyl tape on here. Should be fine. Not quite what was there before, but it'll get the job done. I'm actually going to basically do almost like a double layer here, so I'm going to work my way back up the other way. Alrighty, it's time to get this thing in. So, without further ado, we'll jack the motor up into place here. I guess one thing that I should do here real quick is I want to get some grease on our rotor splines. Let me grab some grease here real quick. We're just going to put this right on the splines of the rotor. Get it nice and spread around. This just kind of takes up any gaps in the rotor splines and cushions any kind of potential gap that there might be. Just makes it so that the splines don't rock back and forth between the motor and the gearbox. That can cause excessive wear and eventually can lead to some serious spline wear issues. I've seen that on a few different types of motors. Early large drive units seem to have those same kind of issues, and I've seen the same thing happen on Fiat 500Es and BMW i3 as well. Might actually have an i3 coming in the near future with what sounds like that might be the issue. Which I've never actually worked on an i3 before, but if it does end up coming in, you'll be able to see it. Anyway, we'll keep bringing this up into place. Alright, so we're nearly lined up with our splines here. We gotta go up just a skosh. Except we're also hitting back here, so that makes things a little tricky. There we go. Looks like again up just a skosh. Alright, so now we can just give this another shove. Boom. And we are on there. Now I just gotta go back through, tighten up all our bolts. I'll try and get whatever ones I can. The old powered ratchet here. That one seemed like it bottomed out. I used the wrong bolt here. Probably did. Yeah, that is an extra long shank on this thing, so. Huh. Okay, guess I need to pay more attention to which ones of these belong where, because clearly they're not all the same. But that one's got to go there because it has a deeper hole that it goes into, because there's an alignment dowel. And there's another one on this side. Okay, we're good there. Okay, so this is our other extra long one. And the ones on top, can I get to? Just barely. All right, and now I should be able to just go through and tighten all those up by hand, and we can start putting everything else together. All right, so it took me a minute of goofing around to figure out why I couldn't get all of the bolts to go in all the way. Some of them were longer than others. I think I realized why, and this was something that I was wondering when I was taking this out, is that I think the guy used the bolts that were supposed to go through the motor to the gearbox and used 3 of them up there on that motor mount, and these longer ones are likely supposed to go there. I thought it was weird that the bolts did not come all the way through there. So I'm going to have to swap at least a couple of those out right now. It looks like, I think to get to this rearmost one, the actual traction inverter has to be lifted out of the way, so that might be a little bit of a pain. But at least for now, I think I'm definitely going to do the front 2, at least to get this thing all mounted in here, and then maybe we can try and get that third one relocated. Alrighty, so I got all the bolts in. I swapped the bolts over from the upper mount here. That was a bit of a pain because I did end up having to move kind of the traction inverter and onboard charger assembly out of the way. But I made it happen. Actually, I'm going to not plug that in just yet because now I want to go ahead and get our motor mount that goes on this side attached. So I should be able to just remove this bolt out of it and kind of slip it in here just like we did when we removed it. And I do need to go up a bit. Oh, stuck on the subframe there. There we go. And get our bolt in, just like so. That is kind of like a lock nut, so I can't quite finger tighten it all the way. And then we've got a handful of bolts to attach the mount to the motor itself, which I might still need to jack the motor up a bit, maybe. I think so. There we go. Alright, so they're all at least started there. Let's go ahead and cinch them down. Okay, now I can go ahead and tighten those. Okay, I just need another wrench here to tighten the last one down. I thought that was a lock nut, but I guess it's not. It's just a little on the tight side. I'm actually gonna swap tools around here because the socket no longer fits on there. All right, we're good and tight there. I can go ahead and plug in our connector here. Snaps on there nicely. Our three-phase connector can be plugged back in over here. Okay, that's on there, and then this rubber boot just kind of sits on top of that. A lot of the little tabs that it attaches to were broken off of that lid, but I think it's on there good enough. Now I can go ahead and reattach our coolant lines. Let me just grab my line clamp pliers, and I guess I can go ahead and drop our jack down out of the way. Okay, there's one hose, and there's two hose. All right, so those are both attached. We can go ahead and take our line clamps off here. And then that's set up there. I was thinking that harness was supposed to attach right here, but that seems like it's a little bit too much tension on it. I guess if I bent the bracket a little bit, but even then, yeah, I guess that's fine. Maybe I know that I bent the bracket at one point, so maybe I just bent it back too far. The little clippy thing for it is actually missing, so I'm just going to zip tie it on there. Nice. Anything else in here that needs to be tightened up? That ground looks good. I think everything is in there. Now all that's left is to get the axle back in, get the suspension put back together, and then we should be able to bleed the coolant. Alright, I've gone ahead and reconnected the high voltage system interlock. Now all that's left to do is to reconnect our 12-volt battery. Just like so. I'll just tighten that down a little bit. All right, now let's make sure that the car starts up as normal, and we'll go ahead and bleed our cooling system. We didn't drain very much, and because we had our line clamps on there, we didn't, of course, lose a whole lot of coolant. So there shouldn't be a ton of air in there, but we will need to bleed out whatever air is in the system. Alrighty, moment of truth here. Key is in our cup holder here. Okay, so I do have some alerts present. Check EV system. Okay, well, we might have to break out the scan tool and clear any codes that were in here. All right, so pulled up all the fault codes. We do have our historical code for drive motor A position sensor low, so that one shouldn't be an issue because it's not a current alert. But we do have a high voltage system interlock circuit high, so I must have something that's not properly connected on the high voltage side. So let me go ahead and double check, make sure everything's good. All right, I suspect that maybe I didn't reconnect this thing properly. Oh yeah. Okay, well, that's a simple fix. I don't know if I can do that one-handed, so let me set the camera down. There we go. I got it locked down nice and secure now. That shouldn't be going anywhere. Go ahead and put our seat back up. Now let's see if it starts. I might still have to go back in and re-clear that code. Oh, there we go. And all the faults are gone, so it actually cleared itself. It'll still be a stored code, which we can go through and clear, but no present alerts. Let's make sure we can go into gear. Of course, it's putting it into park because the door is open. And look at that, it moves. Cool, all right. Now all I gotta do is torque up the wheels, and the bottom cover and stuff over there still needs to go back on. And then we should be able to take this thing on a test drive. Oh, and of course we need to top up the coolant, that's the other thing. All right, I'm gonna do a couple things here. I'm gonna go ahead and do electric water pump control, remove excessive air, ignition on, no TDC, after adding, okay. Yep, so that's gonna run the pump at full speed. We'll be able to make sure all the air gets bled out of it, and we'll top up the system. And then we should be good to go. I'm just gonna set that right there for now. Yep, so it did bleed some air out. We'll go ahead and top that up, and then I'll probably just let this run while I get the bottom covers and stuff on, make sure it bleeds all the air out. Alrighty, and the finishing touch. Got our little cover there. And we should be good to go. It's about time to take this thing for a test drive. I am going to go ahead and do our resolver calibration here. Yeah, so we go ignition on, press OK, ignition off, turn the ignition on, press OK. So it does have a code present for the resolver learning, but the code should clear automatically once it has learned the resolver setup here. And it's important that the resolver is learned correctly for efficiency and all those other reasons. So we'll go ahead and pull out of the shop here, and I'll come back to you guys when we're getting on the road. Everything seems good. Motor sounds a lot quieter than it did before, so that's certainly an improvement. Not getting any, I don't think I'm getting any weird vibrations or anything. This isn't the smoothest road ever. But we'll come out here to kind of the main drag here and get it up to speed. Make sure our resolver offset thing calibrates. And then hopefully after that, we're good to go. All right, just a little update as we're coming up here to the main road. Our resolver offset did clear itself, so that means we're all calibrated, which is fantastic. We'll pull out here. I'm actually going to take it up kind of the road here towards the airport where we can get it up to about 50-55 miles an hour. make sure there's no surprises. All right, we're cruising along here at about 50 miles an hour. Everything seems good. I go give it some throttle. Everything also seems good there. No weird noise, no weird vibrations. I think we're all good to go with this thing. So I'll go ahead and get it turned around here, bring it back to the shop, do some final checks, and then this guy should be able to pick up his car maybe tomorrow if he has time for it. I guess we'll see. Alrighty, well that's going to be a wrap for this one. Fairly straightforward job to go ahead and rebuild the motor on this. Assuming, of course, everything gets done correctly the first time. This was my first time ever dealing with a first-gen Ioniq as far as any kind of repairs go. They seem to be generally fairly reliable, but the motor issues are kind of a known problem that's, as I've mentioned before, kind of shared between them, the Kia Niro, and the Hyundai Kona. And also the later versions of the Kia Soul EV, which we didn't actually get here in the US. But that's basically the same powertrain that the Niro and the Kona use. This one's slightly different. It's a little bit of an earlier version of that powertrain, but it's very, very similar. In terms of everything else that went on here, it seems like we got everything taken care of that we needed to. I'm pretty satisfied with the result. The motor's quiet, and everything else sort of went relatively smoothly, apart from a few bumps and stuff, getting some parts and things. A lot of the bearings and seals and stuff that Hyundai and Kia use are sort of weird, oddball freak sizes. So sometimes you kind of have to figure out some alternative methods to get that stuff going. But anyway, I've actually kind of always liked these first-gen Ioniqs. This was near the top of my list before I actually bought my Model S back over 4 years ago now. And these were kind of in my price range, cars that I was looking at. And the first gen Ioniq, specifically with the smaller battery, like this one has the 28 kilowatt hour, I think 2017 to 2019, I think that they remain to this day one of, if not the most efficient electric vehicle on the road, which is pretty cool. It's very efficient, just doesn't have a ton of range, it doesn't have super fast charging or anything. But the efficiency on these things is really fantastic. But anyway, once again, that wraps this one up. So if you like seeing stuff like this, stay tuned in the future, and we've got plenty more projects coming down the pipeline. Thanks for watching.